In this video, we're going to go through adding and subtracting rational expressions. So let me go ahead and give you the steps we're going to follow, or the process we're going to follow as we do this. So first thing, we're going to find the least common denominator. Now this process was done in section 7.3. So hopefully that's comfortable with you. You know how to find least common denominator. Second step is we're going to multiply the fractions so that they have the least common denominator. And when you're multiplying both to the numerator and the denominator so that you're building the fraction up to have the least common denominator. Step 3, you're going to add the numerators only. You might remember when you are adding and subtracting fractions, you just need to add the numerators. And then the last step, and it's an important step, is you need to make sure that if you need to simplify, you should check to see if you might need to simplify. And when you're simplifying, you're basically looking to possibly have to factor and cancel common factors. Okay, so I'm referring to that process where we may have to factor. It doesn't always happen, but it might, and we need to check for it. Okay, so the very first example I have here actually already has a common denominator. So I get to skip steps 1 and 2, and I'm going to jump right to step 3. I'm going to add the two numerators. Now, I want to point out one very important thing, and that is that we are subtracting. And that matters. When we subtract this numerator, that means we have to distribute the negative into both terms. And the way I do that is I automatically change this into a plus sign, and then I change the signs of the terms in the numerator. So I'm going to make this a negative 11 and a positive z. And now I'm going to go ahead and add the two numerators together. So 16 minus 11 is going to come out to 5. And then z plus z is going to be 2z all over 5z. And then I'm just going to check to make sure that there's no sort of simplifying that I can do. I can't factor the numerator. There's no GCF. So that's done. That's as simplified as that one's going to get. So let's try another one. Again, we have a common denominator, so we don't need to do steps 1 and 2. I do have a negative, that is a minus, so I'm going to change this to plus, and I'm just going to make that a negative 6. If there were two terms, I'd change both terms, but just one term this time. So that's going to become d minus 6 over d squared minus 36. Now, d squared minus 36, that can factor. So I'm going to factor it. That's going to be a difference of squares. So it's going to factor into d plus 6d minus 6. And that's going to actually simplify with the d minus 6 in the numerator. So those two will cancel, those two factors. And I'm going to be left with, well, a 1, because we're never really left with nothing. We're dividing d minus 6 by d minus 6. So taking a number, dividing it by itself, that leaves us with 1. And that's going to be over d plus 6. All right. So let's try something where we have to do a little bit of work. So on this one, they don't have a common denominator. And it's not going to be too difficult to see what the common denominator is. They both have an x in common here. So I just need a 10 on the very first fraction. So I'm going to multiply the first fraction, top and bottom, the numerator and the denominator, by 10. I'm just going to squeeze that in there. So what that's going to become is 100 over 10x plus the other fraction is 1 over 10x. Okay, so now we have a common denominator. So I'm going to add, and that's going to be 101 over 10x. And that doesn't reduce. So there we go. That's my answer. Okay, let's try that again. This time, a little bit more complicated again. We have an x and one denominator, and x squared in the other denominator. And you might remember from when we were doing lowest common denominators, I kind of would break it up the x's. So the first denominator is the 6x squared, and 6 is 2 times 3. The 9 is 3 times x. So to get them to be the same, they have an x in common. I'm not going to go through this process every time. I'm just refreshing your memory. They have an x in common, and they have a 3 in common. So that's going to carry into the LCD. So 3x, and then I'm going to multiply by what's left over. So there's a 2 left over here, an x, and an extra 3. So multiplying that all together is going to be 18x squared. Now, you may not need to go through this process to get to the LCD. Again, I'm just refreshing your memory. So 18x squared is our least common denominator. And so I need to multiply the first fraction by 3 to get the 18, because it's already got the x squared. The second fraction, I'm going to need to multiply by a 2 and an x. So 2 will give me the 18, and then an x will give me that x squared. Okay, so I'm going to go ahead and erase this. And right below, I have 3 times 1 is 3 over 18x squared minus 4x over 18x squared. Now I have a common denominator. So 3 minus 4x, they're not like terms. I'm just going to write that out, over 18x squared. And there's no reducing I can do because I can't factor anything out of that numerator. So that's done. All right. So let's look at this next one. I'm going to zoom in just a smidge. Okay, so for this one, we definitely have different denominators. There's nothing I'm going to be able to multiply by so that they're going to be the same. So both of them are going to be included in my lowest common denominator here. I'll just actually write that over here to the side. So it's going to be x minus 1 and 4x is all going to be included in the least common denominator. So I'm going to multiply this first number, or first fraction, by 4x. And the second one, I'm going to multiply by x minus 1. So the first fraction is going to be 12x over, and I'm going to write this in factored form. I'm not going to multiply it out. That's on purpose. That's because in my last step, when I might be simplifying, I don't want to have to refactor this back out, the denominator back out. I'm just going to leave it in factored form just to save me a little bit of trouble. Plus, okay, so over here, I'm going to distribute the 5. I am going to multiply this one out because I have to add these two numerators together. So I can't have that as a multiplication. Oh, sorry, that's a minus 5. I said it and then I didn't write it. So 5x minus 5 all over, maybe I didn't even say it, 4x, x minus 1. Oops, sorry. Okay, so got the LCD. We're going to go ahead and add the numerators. Now this time we can add the 12x and the 5x, which will give me 17x minus 5 over 4x times x minus 1. Can't factor anything out of that numerator. There's no GCF, so we're done. All right, so let's kind of do that similar process again. Again, I have two different factors in the denominator, so I'm going to go ahead and use them both in my least common denominator. And you might remember, if we can factor these, like if we have to factor them out, we'd factor them first. Look for anything in common first, and then include it in the least common denominator. But we're good right now, nothing to factor. So I'm going to multiply the first one, the first fraction, by x plus 2. Second one by x plus 4. Here, I should put these in parentheses. X plus 4. Okay. So in the first fraction, when I'm multiplying it by 1, there's not much work to do. That's just going to be an x plus 2 over, and I'm going to leave this as x plus 2 times x plus 4. Second fraction, oops, sorry, that's a minus sign, which I'll deal with in just a second. Second fraction is going to be, again, since it's times 1, just x plus 4 over x plus 2 times x plus 4. Awesome. Okay, So let me deal with the minus. I'm going to change this to a plus, and then I'm going to make this a negative x and a negative 4. All right. So adding the numerators, I'm going to get, okay, so x plus negative x, the x's are actually going to cancel out. And then 2 plus negative 4 is negative 2. So the x's are gone. The numbers add up to negative 2 over x plus 2, x plus 4. All right. Okay, so this one, we actually have some factoring to do. I can factor that first numerator as a difference of squares. So here, I'm going to actually write it over here. So that numerator is going to factor into x plus 2, x minus 2. And the second fraction is not going to factor. So just stays x plus 2. Okay, cool. X plus 2 is what they have in common. So for my lowest common denominator, then, I'm going to include the x plus 2 and then the extra x minus 2. So I'm going to multiply only the second fraction by x minus 2 because it's the only one that's missing a factored term for the least common denominator. Okay, so first fraction, I'm just going to rewrite. Nothing to do there. Second fraction, I'm going to distribute that 3, which is going to be 3x minus 6 over x plus 2, x minus 2. And now I'm going to go ahead and distribute that minus sign. I'm going to change this to be a plus and make this a negative 3x and a plus 6. Okay, so adding the numerators, negative 3x is the only term with an x. 12 plus 6 is going to be 18, positive 18, all over x plus 2, x minus 2. Now I can actually factor that numerator, and I'm going to because I'm going to make sure that I can't do any sort of simplifying. So I can factor out a negative 3, and I'm left with x, and that's going to change it to minus 6 because I'm factoring out a negative. Okay, so it didn't end up actually reducing with anything, but that's okay. We should just get into the habit of factoring where we can so that we can check. Get ourselves thinking that way so that we don't miss any sort of simplifying. All right, let's try this one. Another one where we're going to have to factor. First fraction is going to stay the same this time. 1 over x minus 2. Second fraction, though, that's going to factor, and I get to use my x method and my shortcut. So at the top of the x is going to be negative 2. Bottom of the x is negative 1. So two numbers are multiplied to be negative 2, but add to be negative 1 will be negative 2, positive 1. So this is going to factor into x minus 2, x plus 1. Okay, well, that works out nicely because they both have this x minus 2 in common, which is going to be part of the least common denominator, which I'll squeeze in up here. So x minus 2. So x plus 1 is missing from the first fraction. So I'm going to multiply that. And that's going to leave me with an x plus 1 in the numerator when I multiply it all by 1. X plus 1 over x minus 2 in the denominator. And then minus x minus 2, x plus 1. Okay, because it's a minus, I'm going to change that to plus, negative. And now I'm going to add. So x carries into the numerator. The ones are actually going to cancel. And I'm left with x plus 1, x minus 2. And that doesn't simplify any further, so I don't have to worry about that. And that is it.